Symmetry Math. SM is a logical math system for describing the motion of mass. The resultant of arrows is the only math needed. What SM is not. There are no negative numbers or directions in space. There are no positive numbers or directions in space. There are no imaginary numbers. There are no absolute values, and time is not part of space. In SM, all graphs are symmetrical, and the SM circle is based on 2 pi degrees. And in symmetry math, it provides both the magnitude and direction of the resultant of arrows. Symmetry math is a magnitude and direction and arrow math system. SM accurately describes the motion of masses relative to other masses and observers. A magnitude and a direction is an arrow. The magnitude is the length of the arrow. The direction is in the direction of the arrow head. All observers will see an arrow pointing in the direction of the arrow. In symmetry math, the resultant of arrows is the only math needed. The symmetry math number line is you can go in this direction or you can go in that direction. Any math operation operating on an arrow going this way stays this way. Any math operation on an arrow going that way stays that way. Definitions. MP is magnitude at a point. ML is magnitude and a length, a radius or diameter. And MD is magnitude and a direction, an arrow. Mass times distance divided by time is mass times velocity, which is kilograms per second. So M added V times or V added M times, always relative to another mass. Mass times distance divided by time is mass times velocity divided by time, which is mass times acceleration. This is kilograms meters per second square asterisk. There's no such thing as second squared. This is just useful notation. That is mass added A times or A added M times, always relative to another mass. And a mass times a distance divided by time times a distance is mass times a velocity divided by time times distance, or mass accelerated through a distance. This is kilograms meters per second squared times meters. It's mass added A times or added D times, always relative to another mass. All multiplication and division is addition and subtraction is performed by a computer. Numbers and arrows raised to powers. Powers in multiplication is addition, computer math. 2 raised to the third of arrows going this way remain this way. 2 raised to the third of arrows going that way remain that way. In both cases, there are 4 arrows with a magnitude of 2 each. 6 squared to arrow going this way is 6 and 6 and 6 and 6 and 6 and 6 and 6, which equals 36 going this way. There are 6 arrows added 6 times. The directions remain the same. 6 to the cube is the addition you see. Magnitude at a point, MP. MP has a magnitude and a location in space relative to a second mass observer. Temperature at a specific location in space is an example. A magnitude of 2799 degrees where the point 6 in the direction of the arrow and 8 in the direction of the arrow. The temperature inside an oven. A magnitude of 67 degrees points 4 in the direction of the arrow and 3 in the direction of the arrow. Temperature in a room. Magnitude and a length, ML. A radius arm or a ruler. A radius is not an arrow with a magnitude and direction. R is not an arrow. R is a magnitude only quantity. M the mass times the angular acceleration times the radius arms times the sine of theta is equal to the length r times the mass times the angular acceleration times sine theta. The d theta is equal r theta. The arc distance is the radius times the angle theta. In degrees are radians. Degrees and radians are the same value in SM. Magnitude and direction, MD. A MD arrow has both a magnitude and a direction. It will have a magnitude number and a direction arrow relative to a second mass observer. Magnitude times velocity, mass times velocity is equal to distance divided by time relative to a second mass observer. Magnitude and acceleration is mass times acceleration, where acceleration is velocity divided by time, which is distance divided by time divided by time. A useful equation is distance divided by time squared relative to a second mass observer. Again, note there's no such thing in the motion of mass as time squared. This is just a useful notation. SM calculates both magnitude and direction for triangles. The and sign. The and sign means resultant. Add all the arrows for each direction and then subtract to find the final resultant. The table is self-explanatory. The one of importance is the bottom one, where the arrows cancel out and the resultant is equal to 0. The arrows do not equal 0. They are still there. Multiplication of arrows is not allowed. Arrows are added and subtracted only. If you have an arrow of 3 and you try to multiply it times an arrow of 5, it is not equal to 15. There are two arrows. One has a magnitude of 3, one has a magnitude of 5. The maximum of these two arrows can be is 8, a 3 and a 5. If you raise an arrow to an exponent, then you simply add the arrows. Addition is allowed. An arrow has a direction and a magnitude. There are no negative arrows, there are no positive arrows, there are no zero arrows. A zero would negate the definition of an arrow. Something with no magnitude and no direction cannot be the definition of an arrow that is defined as having magnitude and direction. Arrows and magnitudes are still there even if the resultant is 0. In all cases, the resultant is not the magnitude of the individual arrows. If there is a magnitude and a direction arrow, there is a magnitude and a direction arrow. A resultant is the addition and subtraction of the differences in magnitude and direction arrows. Adding and subtracting arrows by the human brain can be time-consuming when large numbers of fractions are involved. To make calculations easier for the human brain, arrows may be multiplied or divided by a number. It must be understood that the only real is addition and subtraction, computer math. Multiplication and division do not exist in nature. Multiplication and division were invented by the human brain as a useful tool for doing addition and subtraction in a shorter time frame. Whenever multiplication or division is used, it is to be understood that the number used as the multiplier or the divider does not change the direction of an arrow. In arrow math, the direction must be specified in order to get the correct answer. For example, a number with a magnitude to the right squared and another number with a magnitude and direction equals 0. From observation of this simple equation, the 3 must be in the opposite direction of the unknown number direction if the answer is to be 0. There is no multiplication of arrows. Multiplying opposite directions is illogical. In number counting math, 2 times 4 is 8 is really 2 plus 2 plus 2 plus 2 equals 8, or 4 plus 4 equals 8. In SM, when a direction is added, 8 in which direction? This has no meaning. Is it 8 to this direction or 8 to that direction? In SM, an arrow of 2 times an arrow of 9 is not equal to 18. This is incorrect. Only 2 9 arrows, which is 9 plus 9, equals 18 is correct. an arrow with a magnitude in the direction of 2 and an arrow with a magnitude in the direction of 9, the resultant will be 2 and 9, which is 11. You can have 2 9s, which will equal 18 here, and there are 2 9s, that is 9 plus 9 equals 18. The resultant of arrow A and B is R. R, however, does not exist. The only arrows that exist are A and B. If R is the arrow, A and B do not exist. They are just useful tools for assisting the human brain to achieve an answer it can understand. Arrows can have magnitude and direction, and rotation on axis of arrow, magnitude, direction, rotations on axis of arrow, rotation on different axes of that arrow. Using SM to solve number and direction problems, SM provides both the magnitude and direction of the resultant of arrows. Here's a graph of d equals t squared. The data is presented as shown below. The particle travels in a straight line. Starting from 0 in the center, I have drawn 8 objects moving from 0. The orientation of the arrow does not matter. All observers will see the same thing, an object moving a specified distance and direction during each second. Arrows can point in any direction. The math is still the same. Time does not move in a positive or negative direction. There is no negative time, there is no positive time. Time is a magnitude-only number that allows the human brain to observe and understand the change between physical and mental observations. The Symmetry Math circle is based on 2 pi. This makes radians and degrees the same number. In Symmetry Math, we use a 2 pi scale rather than a 360-degree scale. This makes radians and degrees the same. The resultant of a number of arrows is a single arrow which would have the same effect as all the original arrows taken together. Note, the resultant is not the individual arrows. It is just a representation of all the arrows combined. If a resultant is equal to 0, it does not mean that no arrows exist. The arrows are still there, just the resultant is 0. Graphical results of arrows. Begin with any arrow and draw the tail of each arrow to the tip of the next arrow. The resultant arrow is drawn from the tail end of the starting point to the tip of the last arrow. The resultant and sign of arrows. Add all arrows for each direction and then subtract to find the final magnitude and direction. A 6 this way and an 8 that way and a 3 that way and a 5 this way is equal to a 6 and a 5 this way and an 8 and a 3 that way, which is 11 this way and 8 that way, which equals to 0. The resultant is 0. The arrows are not. The arrows are still there. For trigonometric functions, instead of having x, y, z's, and r's, we simply have an arrow pointing in the direction it needs to go. And since virtually no one is familiar with radians and degrees being the same, I put in a conversion, an Excel conversion for transferring from BS Math to Symmetry Math. The square of the longest arrow is equal to the addition of the squares of the other 2 sides. Greek Pythagoras given credit for magnitude-only answers. All resultant square of the longest arrow is equal to the square of the sum of the other 2 arrows is usually an approximation. Pythagoras math only provided an approximation of the magnitude. SM provides both an approximation of the magnitude and the direction. The component method for adding arrows. Each arrow is resolved into its directional components, and the resultant arrow is the addition of all the components in that given direction. Knowing the components, the magnitude of the resultant is given by the square root of the addition of all the directions. And this is a template for solving error problems. The next 9 slides will just be examples of how you can use both the graphical and the rectangular component method for solving examples. If you would like a copy of this presentation in a Word format to review, please send an email request to kuysg@aol.com. Thank you for listening.